Um, Good morning, afternoon, or evening from wherever you are hearing me from. My name is Ogunleye Sunday from the Department of Physics Education in Lagos State University. Um, with the matric number 230114046. So today I'll be taking you a lecture through gas law, gas law in physics, gas law. So stay tuned and let's dive right in. Uh, we first take a step in knowing the properties of gas, the laws that are in gas, the laws that govern gases, and there are different relationships covered by each law, which helps describe gas behavior under different physical characteristics. So there are different relationships that covers different gas that we use in different area of our life, be it in our workplace, be it in our homes and offices and the likes. So there are four general laws that relate the four basic characteristics properties of gases to each other. So and each law is titled by its discoverer. That means each law, each gas law is titled, is named after the person that discovered the law. Like if I discovered, let's say, how to make let's say I discover a law relating to air or relating to anything, they can name that law or that thing with my name, just like how they did in Benz, in this car Benz, because the name Benz, car Benz, is actually someone's name. Same goes to Mercedes, and same goes to Ford. The name that they associate with the company is actually the person that invented that that material or that thing. So same thing is applicable in this area. So there are four laws that govern gases. The first one is Charles law. Charles law. The second one is Boyle's law. Third one, Avogadro's law, and Gay-Lussac's law. We'll be looking at the first. We'll be looking at three of these gas law in the space of this video. Let's get right in. The first law in that shows the relationship between gases and how gases performed is Charles law. In 1787, Charles discovered how temperature and volume are related, assuming the amount of gas and pressure are constant. So in 1787, a man named Charles discovered that temperature and volume are kind of related, assuming that the amount of gas and the pressure are constant, which means the amount of the gas in a container, in a certain container, and the pressure in that container are constant. So he was able to discover the relationship between the temperature of a gas and the volume of a gas, how they relate, what 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 connection they have between each other. So an increase in temperature will lead to an increase in the volume of the gas, which means if there is an increase in the temperature of a gas, there will be an increase in the volume, with the representation in this in the picture right here, that volume is directly proportional to the temperature. Volume is directly proportional to the temperature, which means V1 over T1 is equal to V2 over T2. That is the mathematical expression of the equation of the law. And the graphical representation that shows that when the temperature of a given gas increases, the volume also increases, which means when you increase the temperature of a gas, the volume of that gas will increase as well. So as time goes on, we look at other laws that applies to other aspects and other qualities that affect gases. This is Charles' law, and it showed us the relationship between temperature and volume and how it affects gases in constant pressure and at a constant amount of volume. So think of it this way: if you increase the volume of a gas and must keep the pressure constant, the only way to achieve this is for the temperature of the gas to increase as well. So if you want to keep if you increase the volume of a gas, if you increase the volume, let's take for example with the graphical representation, diagram representation in this slide, you will see that when the temperature is applied to this volume, to this gas, you will see that the volume actually rises, the volume increases. This is the V1. You will see here V1, T1. The T1 represents the temperature and the V1 represents the volume. So when the temperature increases, the volume also increases. In order to maintain, you know that from the law of particle of nature in physics, we know that every matter possess an kinetic energy. A kinetic energy in place that they move at random and constant motion. So, and the higher the temperature of any material, the higher the kinetic energy of the molecules. And in this aspect of gas, in order for you to maintain the volume or the molecules to be at constant speed and constant rate, because when you increase the pressure of any gas, when you increase the pressure of gas, you indirectly can also increase the temperature. We also look at that as time goes on. But in what Charles' law is trying to tell us is that when the temperature of any volume or any volume of gas is being increased, the volume as well increases in order to maintain a constant pressure in the volume, a constant pressure in the gas. Look here, you see that the volume here, the volume in the first diagram is compact. They are compressed together. But when you increase the temperature in T2, when you increase the temperature, you see that the temperature has risen up. When you increase the temperature, the molecules, the volume also increases. The kinetic energy also increases. It gains more kinetic energy and it increases in its volume. And that is what Charles' law is trying to tell us, that when you increase the temperature of a gas, the volume of that gas will also increases. So with this will lead us to the second law of gases, which is Boyle's law. So in 1662, Robert Boyle discovered the relationship between pressure and volume. assuming constant temperature and amount of gas. This is trying to tell us that in 1662, a man named Robert Boyle discovered the relationship between pressure and volume, assuming that the temperature, the former one was that in the Charles law was that pressure was constant, but here temperature is constant. So Boyle's law is just trying to show us the relationship between pressure and volume, how the pressure affects the volume of a gas if the temperature is constant. So if the temperature remains constant as the volume of a container increases, the pressure the gas will exert will decreases, which means that if the volume of a container increases, when you increase the volume inside a container, the pressure of the gas will decrease. And likewise, when you increase the pressure of a gas in a container, the volume will decreases. When you increase the pressure, the volume will decrease. When you decrease the pressure, the volume will increase. So here is the relationship that shows pressure is inversely proportional to the volume, which means pressure is inversely proportional to the volume, which means as pressure increases, volume decreases, and as volume decreases, pressure increases. The equation shows here is P1 times V1 is equal to P2 times V2, showing in mathematical that is the mathematical representation of the theory of the law. Using the inverse law in mathematics, we were able to get this equation. And the graphical representation of the law as seen below, that when the pressure increases, the volume will decrease. When the pressure increases, the volume will decrease. Therefore, as seen as volume increase, pressure decrease, or pressure increase, volume decrease. Sorry for that. The reduction in the volume of the gas means that the molecules are striking the walls more often, increasing the pressure, and conversely, if the volume increases, the distance the molecule must travel to strike the walls increases, and they hit the wall less often, thus decreasing the pressure. What is meant in this short sentence is that see this, when you increase the volume, you will notice that the molecules, the speed that the molecule has is being reduced. Let's look it this way, that the speed of a molecule is directly proportional to the pressure. So when you increase the volume, you see that the molecules can move freely. You see all these red dots, let's consider it as a ball. When you increase the volume, you give them space to move freely, to move slower, and they will be free. Whereby increasing the volume, when you increase the volume, the gas will be free, and it will have less and less kinetic energy. That is increase in the volume and decrease in the pressure, because they are not hitting each other. Let's consider the pressure as the compartment of the volume, the compartment of the molecules, whereby they will be hitting each other. They won't have space to move. That is what is here in the second diagram. Here you will see that the molecules here, they are moving fast and they are hitting each other in a short time, which means this is an increase in pressure and decrease in volume. This, or we can also say a decrease in volume and an increase in the pressure. In the smaller space, these particles suffer more collision with the walls of the container. It is this that we measure as pressure exerted by the gas. This is when this is what is meant by pressure is exerted by the gas, because there is pressure, there is compression in the molecules that the gas has. Hope you are getting the idea and the law that governs these gases. This moves us to the next law, which is Avogadro's law. Avogadro's law. In 1811, Amedeo Avogadro was able to identify the correlation between the amount of gas and its volume, assuming that temperature and pressure are constant. So Avogadro actually identified the correlation between the amount of gas and its volume, which means the number of molecules a gas has and the volume of the gas. Avogadro is trying to tell us that the more the molecule of a gas, the more the volume of that gas will be. Let's say you pour 1 liter of water into a keg. It's trying to say that 1 liter of water will occupy 1 liter space of that keg. That is what Avogadro's law is trying to tell us. So an increase in the amount of gas will also increase the volume of the gas. That is what I just said and gave as an example just now. That if you put 1 liter of water into a keg, that 1 liter of water will occupy exactly 1 liter space in that keg. That 1 liter of water cannot occupy more than the amount of the molecule. Are you getting me now? That is what Avogadro's law is trying to tell us, that equal volume of all gases under constant temperature and pressure will occupy the same volume as equal to the number of the molecules, with the relationship here, which is volume is directly proportional to the amount of gas, which also means the volume of a container is directly proportional or equals to the amount of gas present in that container. With the graphical representation of V1 over N1, V1 which means the volume, N1 which means the number of molecules, is equal to V2 over N2. Graphical representation, which means as volume increases, the number of molecules also increases. As volume increases, the number of molecules also increases. If the amount of gas in a container is increased, the volume will also be increased. If the amount of gas in a container is decreased, the volume will also decrease. Just like we see in this image representation, that if the volume of this gas decreases, so the number of molecules, you see that the molecules too are little and small. But when the volume is being increased in V2, you will see that there is more molecule in the container, and there will be less or decrease in pressure in the container. You can now relate this to other laws that we discussed previously just now. So that leads us to our next law, which is Gay-Lussac law. Gay-Lussac law. Gay-Lussac law, or what Gay-Lussac law is trying to tell us, is the relationship that exists between temperature and pressure of gases. Gay-Lussac law is trying to tell us the relationship that exists between temperature and the pressure of gases. The first law we treated was Charles' law, that tells us the relationship between volume of a gas and its temperature, while the pressure remains constant. The Boyle's law tells us the relationship between the pressure and the volume, while the temperature remains constant. And Avogadro's law tells us how the number of molecules can also affect the volume of a gas. Now, Gay-Lussac's law is trying to show us the relationship that exists between the temperature of a gas and the pressure of the gas. That means, what is the connection between the temperature that is in a gas and the pressure that you apply to the gas? Given a constant volume, trying to maintain a constant volume, what will happen to that gas? If to show the relationship and between the temperature and the pressure. So if the temperature increases, the pressure will also increases. That means if the temperature increases, the pressure increases. Remember, I told you earlier that the molecule of a gas, they are at constant motion. They have a kinetic energy. They are at constant motion. They move randomly at constant motion. So the only thing that increases their motion, the only thing that increases the motion of the molecules of a gas is increasing the temperature. You know that this is how you should look it. What Gay-Lussac law is trying to tell us is kind of simple, and you should look it this way. I told you just now that kinetic energy, from the nature of matter, all matter has a kinetic energy, be it solid, liquid or gas, and in gas is the fastest. That this kinetic energy means that all molecules of a gas, they are in constant motion. They are always moving. And if you want to increase the speed of these molecules, you will have to give them energy, and that energy is the temperature that you will apply to the is the energy that you will apply through heat source. Heat is a source of energy. Heat is different from temperature. Temperature is the degree of hotness or coldness of the body, while heat is an energy. Heat is a state of matter. It's not a state of matter actually, but it is an energy that can be transferred. So back to our point. I told you that temperature generates heat. Temperature generates energy, which is heat, in form of heat, and heat is an energy. And in order to make these molecules move faster, they need an extra source of energy so that they will be able to move faster than the normal position they are. Are you getting me? So when you increase the temperature of a gas, when you increase it, you are increasing the energy, and that energy will flow into the molecules. That energy will enter into the molecule and we be able to fuel them. We give them more energy to speed. And when they are moving fast, when the temperature is high and they are moving fast, you will see that they will be eating themselves. Just let me go back to the PDF here, yes, so that we can have a perfect picture of what I'm saying. So when the temperature is increased, these molecules will gain much energy. So they will be able to move fast, and when they are moving fast, they will be eating each other. They will be colliding with each other, creating a pressure. Do you see now that is where the relationship between temperature and pressure comes in place? That when you increase the temperature of a gas, the molecules will begin to move fast. And when they begin to move fast, they will be eating each other. They will be colliding with each other. And when they are colliding with each other and with the wall of the container, they will be exerting pressure on it, which will lead to an increase in the pressure of the gas. It's as simple as that. Do you understand it now? Yes. Let's move on. That is what Gay-Lussac is trying to tell us. And the perfect relationship is pressure is directly proportional to the temperature, which means as pressure increases, so temperature increases. The equation here shows P1, the mathematical equation shows that P1 over T1 is equal to P2 over T2. Then graphical representation here, you see that the pressure increases, the pressure with the unit ATM, that is standard atmospheric temperature and pressure. So the pressure, as it increases, the absolute temperature, degrees Celsius, also increases. That means if you increase the pressure of a gas too, the temperature will increase. It's just like you blow air or you blow gas into a balloon, then you tie it. You know that when you are tying it, you are putting pressure on it, you tie it to the extent that the gas, the volume of the gas is being decreased. When the volume of the gas is less, when the volume of the gas is being decreased, you will notice an increase in temperature. You notice that the balloon is warm, and that is a perfect example for us to show all this law that we just discussed. The perfect example of a balloon shows a good example of the relationship that when you increase the pressure of a gas, the volume will decrease. You see that when you blow into a balloon and you begin to tie it and you decrease the temperature and you increase the pressure, you tie the balloon, you see that the volume will continue to decrease. That is what Boyle's law is trying to tell us, that when you increase the pressure, the volume of the container will decrease and the pressure will increase. You see that when you keep on tying, the volume of it will compress. It will compress. That is what happened here. The volume will compress, and once it's compressed, it gives an increase in temperature because it will produce heat. It will give an increase in temperature and also a decrease in the volume. Do you see now? There are three entities that we are looking at in the gas law. First thing is the volume, second pressure, and temperature. How they relate in gas law. And these I've explained the laws that govern them, and with the example you should be able to understand better. So if you heat a gas, you give the molecule more energy so they move faster. That is what I just explained, that if you heat a gas, if you put heat, if you put fire to a gas, you give the molecule more energy, you give them heat energy to be able to move fast. This means that they will impact this means that more impact on the walls of the container and increase in the pressure. More impact on the wall of the container will lead to an increase in the pressure. Conversely, if you cool the molecules down, whereby you remove the energy, they will slow down and the pressure will be decreased. Which means if you remove the temperature, it's just like boiling water. You put water on the fire and you increase the fire, and the fire is boiling, the fire is very hot. You see that the water will be shaking, will be shaking and trying to fight and giving pressure, boiling like that. But if you reduce the temperature, if you reduce the fire, you see that they will calm down. So that means if you increase the temperature, the fire the water will give a lot of pressure, will be violent. But when you decrease the fire, they will calm down. That is what Gay-Lussac's law is trying to tell us. So with all this law, it leads us to the ideal gas law. And what ideal gas law is trying to tell us, ideal gas law is the fundamental gas law that combine that we get from all the other gas law. It's a relationship that shows the relationship. It shows the relationship between all the gas law that we just mentioned. So ideal gas law, in a simple sentence, in a simple definition, shows the relationship that link all the gas law with the equation PV is equal to nRT. P sorry P equal to absolute pressure of the gas, V volume of the ideal gas, N the amount of gas, T absolute temperature, and R gas constant. So note, the gas constant has different values that can be used depending on the unit. The most common ones are the following. So the gas constant, like I said, ideal gas law is just telling us how all the gas law relate, and the constant there has a different value that can be used depending on the unit. So we have 8.3145 joules. That is one unit that we can use, joules per mole Kelvin. And the SI unit also that is also there is 0.082057. So with this, in most cases you won't really need the gas constant, because it will be given to you in the question that you will be asked. So this will come to the end of the class. If in any area that you don't understand, you can as well go back through the video. You can pause the video, go back through the video, watch it over and over again to grab the idea. And any question you have, you can drop it in the comment section. Just drop it in the comment section. I will view it. I want you to click on the like button and head over to clicking on the subscribe button. I will see you later. And before I go, I would like to reintroduce myself. I am Ogunleye Sunday from the Department of Physics Education in Lagos State University with the matric number 230114046. It's nice meeting you and nice lecturing with you today. And it's with time you see more. I will upload more video of me lecturing or breaking down complex topics for you. Bye for now.